So, welcome to the first live coding session for BitShares using Python 3. The plan today was to go via like the first basic setup of the witness node and the wallet, and then start like very simple interfacing with the both of them. I assume that you have already the BitShares 2 wallet and witness node running. And the first we need to kind of execute the both of them, open up an RPC port, and later we're just going to use the library to play with them. So over here I'm in the directory that has the web wallet, the wallet, and the witness node compiled. We can start the witness node relatively easy with it's located in programs, witness node, and all we need to do is add an RPC endpoint, and the endpoint is just like the IP address and the port to listen to. We could put it like this. It would make it listen to all the interfaces and doesn't make it available throughout the internet, except you're behind a NAS or something, net or something. Or you run it via localhost only here as well, localhost 8090, and then I could just hit enter and start up the witness node. I already have a witness node running in a screen session. This is it, so I don't need to do that. The second application we want to run is the wallet. First of all, the witness node alone cannot do much. It just gives you a API to access the blockchain as a database. You can request data from the blockchain, but you cannot send any transaction and let the witness node sign something, because the witness node does not know private keys or anything. But the wallet does, and we can start the wallet with called cli-wallet like this. It would open directly up. It has some seed nodes integrated already, but we want to start it first of all against our local witness node. This looks like this: WebSocket connection, and we have it running. At least it should be running over here. Okay, so it connects in there, and now we have to open up a RPC port for requests that go to the wallet, and we do that by this, and we choose another port, 92 for instance. Okay, now we have a wallet running. We can do anything that the wallet allows. For instance, get account N or get account committee account or anything, and there's quite a lot of data that you can pull from the cli-wallet. There's no real console for the witness node, but we can use Python later to pull data from over there. So that was the easy part, just opening up two small applications. Let's switch over to the coding part. Here we are. So this is a simple editor, as you will see. And no, let's first. I forgot something important. We need to install the library first. Okay. So we want to install the Python libraries, and we have two options actually. The most easy option would be to use a pip install. It's called graphene lib. And if you run that as a regular user, it will most probably fail. Okay, I have it installed already. upgrade it will upgrade. Okay, yeah, I found it already in my local directory. You would probably need to add a // user to have it installed directly in your local thing. If you want it installed in your global directory, then you have to run it as administrator. This is one option to install it. Alternatively, you can clone the original source code, and this is what I usually recommend people to do. Simply because there are some scripts integrated that you might want to use. For instance, the price feed script or something. Down from GitHub. Yeah, python-graphene lab, and now all we need to do is make install user. And it would simply install it into your user directory. And as you can see, the version I'm using here is 0.33. Okay, now we have Python running, and I think we can go over to the funny side of things and interface with Python a little. Here we go. So. Okay. Good. This is a VI editor. You will see later that when I execute this application, the application is called Hangout Py. You can see it down here. And I can execute it later by Python 3 Hangout Py. That's what's going to happen, and it doesn't show anything. So I can print hello here, show it down here, just that you know what's going to happen. Now, since we're going to use the Graphene API or the Graphene client, and not all of the other stuff that is part of the library, I'm going to focus on that one for this Hangout, and I'm going to focus on the Graphene client, which is already like a second. Yeah, it adds an abstraction layer into all of the difficult RPC and WebSocket stuff, and makes using especially the WebSocket stuff a lot easier. Okay, we have that included. Usually I also include a pprint because it makes plotting stuff very easy. And now we're going to open up a new class, and we're going to call the class config. This class has just the settings we want to use for our wallet. We're for now just focusing on what the wallet can do. And a wallet host, wallet port. That's the port we had earlier when we launched the cli-wallet. We launched the cli-wallet like this. So that's why we use the port here and the local host. And good. So this is basically the configuration. And we now open up a client with our settings. It looks like this. And we can take a look at what client is. It says client is not defined. Client. Okay, it's something. Give some error messages, whatever. Okay, so now if I want to execute something from the wallet, I'm going to call the methods like this. What's going to be the first one? Get object 2.0.0. This. Yeah, no one noticed. I'm writing here 8092, and here's 8090. That's wrong. I need 8092. Run this now. I should get, this is the data from the object 2.00. For those that have not yet read through the API, Graphene uses objects basically for anything. 2.2.2, let's start like that. These are separated into 3 digits or 3 numbers, x, y, z, where x is usually is 1 or 2. It gives, they call it implementation, and it distinguishes basically between what is blockchain level and what is more abstract level. Blockchain would start with 1, and 2 would be the more abstract stuff that is kind of based on top of the blockchain. Y is the type of the object. There are many of them. Let's take a look. Object types. There are 16 of them, as you can see. So, for instance, if we later will see if we want to have an account has something that starts with a 1. It's protocol ID 1.2, and then comes the set. The set gives the identifier. Okay, so 2.2.2 is something rather special. It gives you the global parameters. So the fact that here's a 2 already states that this here doesn't really work out. But if you start with a 1, for instance, 1.3.0, now let's start with 1.2.0. 2.0, you will see that this is an account. It looks like an account, and the account name is committee account. And you can see it already here. There's also the account ID. There are some other parameters like the authorities. This is something special for the committee account. Blacklisting stuff, owner options like the memo key. There's no real memo key for the committee account. And these kind of things. Ah, that's interesting. Anyway, we can also take a look at the assets. And for the asset, we go here. We see, okay, assets have number 3. So we just take a look at number 3, and we see that number 3 is actually an asset that's called symbol name BTS. And there's some other stuff, for instance, the core exchange rate, and some parameters like flags and permissions and max supply. Okay, so now we have some objects. I would recommend, if you really are coding, to not use RPC get objects, but instead use this here, because it has an integrated buffer. So if you're using get object very often and want to spare some of your network load, then better use the get object. It stores it in a sorted kind of list to reduce the load on the network. Okay. So we can, of course, also initiate transfers. That's quite easy. All we need to do is something like this. Okay, if you don't know how the transfer command actually works, you can always take a look at what is written over here. We'll give you an introduction or a brief overview of the API calls that are available from the wallet. And transfers, if I recall correctly, work like this. This is the sender, this is the receiver. I want to send 10 BTS. This is a memo. And the last and final flag is either a false or a true. It's a broadcast flag. If you have the last flag at true, it will broadcast the transaction. If you have it false, it will only display it to you. You do the very same thing in the console of the wallet as well. So look if I made this correctly. No, something was wrong. Oh yeah, there is something wrong. As you can see, it stated that the wallet is locked. Let me quickly unlock the wallet. First check the wallet. Okay. So wallet is unlocked. Now what you can see is a so-called signed transaction. The signed transaction contains a expiration, a usually empty extensions field, a set of operations. There's currently just one operation in it. Then there's a reference number for the block that is used here. I'm maybe interfacing with the wrong network here. What happens if you have too many of these running? This is the block num. This is not the number. I think I'm not 100% sure what's going on here. Why it's 1,000? It should be the block number, as far as I remember. But it may be truncated to the last digits. Anyway, there's also a prefix, and this is the most important thing: the signature that has been derived from the private key in your wallet. So this transaction has not been executed simply because we have a false over here. If you wanted to do it really, then we can put it a true. From our perspective, nothing really changes except maybe the signature, but we can see later on the blockchain that something has changed. Instead of using transfer, which gives you a transaction, we can also use transfer to, I think. That should give you the hash of the transaction as well. Right. So this is now an array. And the first element of the array is a signed transaction. That is a hash of a signed transaction, the transaction hash, usually called. Okay. Good. Now what we can now do is we are going to take a look at our history. And to do that, we call count history, I think, and we are limiting this to 10. Let's see what happens. Okay, yeah, this takes a little because it gives you the last 10 and decodes them and gives you all of the data. Let's see what happens if you just get 2. Okay, these are the last 2 transfers. So what we can see is these are 2 of them. There's a description field that says transfer from Xerox to Fabian with a memo and for BTS fee, and the same thing over here again. Oh, there's a question. Let's see. I think I moved. There's something moving around here. Okay, sorry for that. I think this is going to reflect this. Muted. I can't unmute here. Just. I don't know how to unmute you. It won't let me unmute you. No one?
Okay, I think now it should work.
I can hear you.
Okay, I have a question to the thing which you did previously or a few minutes ago. You had a problem that wallet wasn't unlocked.
Yeah.
Is it true that all transactions or all operation has to be on unlocked wallet? And did that mean, can you unlock it from the code?
Yes. Let me go over here. So this unlock thing, you could do so. It is essentially works the very same thing. RPC dot unlock code something. Let me see what happens. Yes, this is not my passphrase. That's why I get an AES error. So you can do you can call this unlock here. And what you can also do is you can take a look whether the wallet is locked or not by calling is locked. False. So it is not locked. It is unlocked.
Okay, thanks.
You're welcome. Okay. The account history. Let's get back here. We see these two entries here. Note that there's a description that says what happens and includes the memo, assuming that the wallet has the memo decryption key installed. If it does not, it will state that it cannot decrypt the memo. Then also these operations here that take part. We can take a closer look over here. The operation is actually an array, and that array has the first entry be the transaction, the operation type. Being 0, which is a transfer, and the second one would then be the content of the operation for the transfer in this case. They usually all have a fee. Most of them might have an extension eventually. And then for the transfer, there's a to field, which contains the ID of the account, a from field, which contains also an ID of the account, the amount, which contains not only the asset ID, but also the amount in Satoshis. So there's the precision involved here. And the memo. Memo is I think that's a topic in its own that's probably going to need a own Hangout session. But it contains the message and kind of how to derive a shared secret kind of thing. But I think that's going to discuss. It's going to discuss something else. Okay. Okay. So let's take a look at assets. For instance, the US dollar asset. Okay, yeah. So we have an asset. The symbol name is USD. And we see here already that there's a precision that is 4, which means that if you want to calculate from the Satoshi's value, let's say this is the Satoshi's value, and you want to derive the US dollar values, you need to multiply by 10 to the power of the asset precision. So all the data that is given from these get asset and get object and whatever calls you do are all interpreted as JSON. That's why you can run something like this. So, oops. Print USB. Oops. Can you see what the, okay, the Satoshi values. Okay, of course, Satoshis are integers, and I need to divide by the precision, of course. Yeah, this would be 1000. Okay, so this is about the precision. Then there is the issuer. In this case, this is the account 120. We already know that account. That's committee account. The asset has its own ID, starting with 1.3. in the identifier. And they have two further objects associated with them, with this particular asset, which the first one would be the bit asset data, and the next one would be dynamic asset data. The first one corresponds to the feed data, price feed data, and like collateral requirements and margin call and short squeeze, protection ratios, and all this kind of stuff. And the second one, actually, I have no clue. Let's take a look. And get object. Oops. Two dot three. Okay. Oh yeah, accumulated fees, confidential supply, all of these kind of statistics kind of stuff. Okay, I think that's not going to be very much interest over here now. Okay. So much for that. I think we're going to extend this fun a little and are going to call some methods from the WebSockets. And in order to do that, we need to tell what WebSocket we're going to use or what witness node we're going to use. And for that, we need a witness URL. At Vienna, the difference between transfer and transfer to is only the transfer to does give you a hash of the signed transaction together with the signed transaction. Transfer to gives you an array of two values, and transfer gives you just the signed transaction. The hash of that signed transaction can be used later to figure out whether there has been a operation added to some block with that hash. So there's something like get recent transaction hash IDs or something like that in the WebSockets. We can take a look later. Okay, back to the witness. We need a witness address. We could use, for instance, the one from OpenLedger. That would be like WebSocket secured BitShares OpenLedger .websocket or something. Or we use the one we just had installed and have the witness also connected to. Should be that one here. 1.2.7 8090. And we can access now the witness node simply by client.witness or WebSocket dot something. You can just put something and take a look what happens. Not sure if whether an info call exists, and obviously there's no info call. But fortunately, it tells you already what calls are available. For instance, which one do we take? Get block. Maybe it's going to work like this. It's the block number 10, and it has no operations. Interesting. There is a bunch of calls you can make on this WebSocket thing. They are over here. Now, there's one important thing that I need to tell you right now. There's actually more than just one API in the witness node. Let's get back to this here and call anything. I'd tell you that somewhere. No, it does not tell it. And you need to know that. There's actually more than just one API. There are several. For instance, there's the database API. There's the network node API. There's the network broadcast API. There's the history API. I think there's also a crypto API. And I think that's about it. Basically, you only need that one. And maybe you want to look at that one. But the other ones are usually not so interesting for the end user. Let's take a quick look at the cli-wallet here. No? We'll look at the cli-wallet first. So what the cli-wallet here does, the graphene client does, let's go down a little here. The graphene client here, that's the instance you're working with. It has an RPC and the WebSocket thing. And the WebSocket, where is it? What did I want to show you? Here is a WebSocket, graphene WebSocket protocol. And that's written over here, WebSocket RPC. And we can see over here in the init that it connects or registers to the database, to the history, and to the network broadcast API. That's actually what happens over here. And to make it easier for you to use these and distinguish them, you can simply call API is database. That probably won't change anything because with the database you can always, oops. Yeah, the get block is a call from the API, from the database API. You can do that. You can send all of these calls also to any other API, but yeah, in the history API, there simply is no get block. But for instance, a get account history. Or was it a get accounts history? Account history. All we now need to know is how the code is, how the parameters are, because that is something the API won't tell you if you do it wrong. Let me give you the link. This is data about this, and get account history looks like that. So, okay. Honestly, I must tell you, this API is a little unpleasant to use, really unpleasant to use. First of all, because, yeah, very important fact, if you're dealing with the WebSocket connection to a witness node, you can't really use account names. You will need to use account IDs. How do we deal with that? Very easy. Get the whole account, get account, for instance, my account. And then we just hand over the account ID over here. Okay, operation history ID type. That is something even worse, actually. Let's take a look. I can't remember how I did this. Let's go over here. So, okay. Fast stop. 1.10. Okay, let's try that way. So this is a object ID that identifies an actual operation. Then we can say I want to just get one of them, and I want to stop. Yeah, whatever. This has to be. Let's take a look if it works like this. Oh yeah, here it is. This is a operation in the block number, whatever, 4 million and something. As you can see, this is the actual op ID, the last one, the last operation ID that took part in that account. And I guess it transferred 10 BTS. BTS has 5 digits, 1, 2, 3, 4, 5. This is exactly 10 BTS. BTS because there's a 0 here. Some fee, and it goes from account 282 to 880. And I'm pretty sure that 282 is Xerox and 880 is Fabian. So this is exactly the operation we did earlier. Interestingly, the operation ID, this one should be unique. So this identifies your operation from the set of operations that is available in the blockchain, and they are ordered and yeah, like immutable. They don't change. So this very operation will be there and will always be identifiable on the BitShares blockchain as the one that carries the number 1,736,009. You can just pull this thing and you will get the whole very same thing. And client get object. Here it is. The same thing, as you can see. Okay, so this is the history API. There's also, as I told you, the database API. Let's take a look at the database API because there's quite some stuff that you might want to use eventually. You can get a list of things that are available over here. So cancel all subscriptions. That's not so important unless you really are using a continuous kind of you let the Python. We are going to do this in a minute. We have half an hour left. This is something new, like getting volumes of markets, account balances, get account by ID. That's by name. Account count. That's interesting. Let's get the number of accounts we have. Get account. Accounts count. Memory so bad. Account count. Okay. We have 100,000 accounts already in BitShares. That's nice. So what do we else have? Chain properties, chain ID. The chain properties are actually, this is just an alias name for getting the object 200 or 201, I'm not sure. Okay. Interesting. I was wrong. There are quite a bunch of parameters in the blockchain. Good. Yeah, I think I don't need to go over all of these because there's a bunch of them. You might notice that there is actually no get object, but a get objects. But still, you can run get object here. That's something I hacked together just because I wanted it that way. It feels more convenient. Get object is nothing more than get objects with using one thing in an array. That one, short. Just if you start to wonder when you're working with it. Okay. One more thing that I have copied over here that I want to use or show to you, the market history. Let's move all of this stuff down here a little. So, print client.websocket get market history, and that call takes a bunch of parameters. First of all, we need a market that consists of 2 assets. Let's take a look at the MKR versus open.btc market. And over here we need the quote ID. 1 second. We have quote ID, we have base ID. You can do it the other way around as well. It's essentially the same market. It has to be the same market. Just the numbers are a little different because they are inverted, but anyway. So these are the two assets. Now there comes something that's called bucket size. You know that pretty much if you take a look at market history curves, you can always select something like 1 second, 5 minutes, 1 day, or something that's bucket size. And we can have a bucket size of 4 hours, for instance. Now there's a starting time and an end time. And in order to make it a little simpler, I have a method here that I'm going to paste here. This method does nothing more than format a time in the proper standard way of formatting time. The way it looks like this, it's a year, month, day, then there comes a T, then there's hour, minute, seconds, but I don't want to deal with that, in particular if I just want to relate it to now, which is this one. So I can say, okay, I want the last 24 hours. And compare it or stop today or now. And if I call this right now, this will probably not work. Oops. Because of that, sure. Date time and import time. And now we see that we're doing it to the wrong API because we're usually just pulling the database API, and in order to get the other API, we just call the add here API is history. Let's see what happens. Okay, this is the data from the last 24 hours. The markets are not very old actually, because the asset is rather new. And we can take a look over here what happens. All these numbers here, except for the objects, are Satoshi values, so base volume. If you want to interpret this, you need to take a look at the base. The base precision, close price, close quote, high, low, open, and then there's also a key that gives you the sorting with it. So that if you have this, you can always identify the base asset and the quote asset, and then how big a bucket we actually had. Okay, so now we have 15 minutes left. Let's go over to something that may be interest to some. So now what I want to do is I want to extend the whole thing for the Graphene WebSocket protocol. So I'm going to add something above here. This is Graphene API.graphene protocol import Graphene WebSocket protocol. This is a protocol that deals with messages that come from the WebSocket when you start doing notifications. So what's going to happen is we're extending the whole script so that it runs on its own. It won't terminate on its own. It will run and wait for the WebSocket or wait for the witness node to answer any questions or to notify me of any changes that might be of interest to me. So for this, I need this Graphene WebSocket protocol, and I need to add this to the configuration here. Oops. Because now you will see why this is a class, because we're going to extend this class by some methods. Let's move this here. Okay, So the whole idea is very simple. All we need to do is we need to run the client. And this should actually already work, except that nothing will happen. Do this with a Control-C. And now what we're going to do, this is why we need this to be. We are going to do something whenever we have registered to the database, for instance. This will be a one-time event. So our Graphene client will, the whole procedure, let's go through the whole procedure first. The whole procedure is, first, establish a connection. And second, we're going to log in. If you don't provide any data, any information about how to log in, it will use an empty username and a password. Then the third thing that will happen is we're going to register to APIs, and this one will be database. At least, I think we're also going to register history, and I think that's about it. It may be, I think we're also in network podcast. Registering in this case means that I get a unique ID from the witness node that I can use to actually call something within that node. But all of this you don't really need to know because it's very easy to, it's actually abstracted away. But whenever I connect to any of these APIs, I can get notified in the class above. So once this is done, I can also register for notifications of changes to an account, and I can be registered to notifications of changes of a market. I guess those two are going to be discussed in the next coding session. Anyway, let's get this working. Just click on register database. Print database registered. Def on register history. Self print history registered. Of course, you can't know all of these like methods. You can what's called in English, override. But of course, you can always take a look at the IPA code. Find here. It's an example config. This example config is actually what we are going to write over here, or yeah, kind of thing. There's a bunch of documentation in here, and it tells you already what kind of things you can do. For instance, we can also add a on account update. This is something that needs to. Yeah, we're going to need to discuss this first because we need to tell the client which accounts we are actually looking at. That's why we have here watch accounts and watch markets, by the way, for those that can't wait for the next session. There's something called on market update. There's also something on block. Let's take that one into consideration. Print data. We print the data over here. Those don't have any data because this is just like an event. It changes, that is, if something on the blockchain like parameters like fees or anything change. Register history, database, network node, broadcast. Okay. So let's start first without the block and run this, and it's there. Okay. What we have is we are connecting to our local witness node. WebSocket connection is open. You're registered to the database, and we have registered to the history successfully. We can, I think we have time. Let's take a look at what actually happens behind the scene. we're going to do this and message and this. Okay, and what we can see, oh, this is a lot of bunch. There's coming a bunch of data. Oh no. So this is what happens. We're going to log in. Then you register in database history network node, network broadcast, and these are the replies from the server. They come after some time, and that's why all of this is asynchronous. This is like login is successful. This gives us a response for the database registration. This is a subscription callback. We're going to discuss this later. And this is the successful registration for the history and a successful registration for whatever network broadcast. ID 5, ID 5. This ID 7 here, this subscription, is something we're going to discuss next time. Okay. So now let's take a look at the blocks, I'd say. So let's do it. We have everything registered, and here comes a block. And another block. No. Oh yeah, we have 3 seconds blocks. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yeah. So this is actually our blocks. I am not 100% sure they contain operations in this call, but we can try this. Just generate another 10 BTS transfer. No. True. It seems these blocks are without the operations themselves. Okay. So now let's just get this one thing done. You know what this is all about. We're going to add accounts. And I'm going to watch my account over here, and here. And add this here and pprint data. And now I'm going to open up this, and there shouldn't be anything happening because nothing is saved into my account. But I can change that. I can transfer something over there. And something happens, as you can see here. There's now a ID involved. The ID involved is, you might recall this 880. This is actually the identifier for my account. This 6 tells me that this is an account. No, this 6 tells me that this is a, not an history object, but a, like a statistics for the object, for that account. It gives me some stuff like, yeah, this here. The owner is 1.2.880. This is the actual account. Pending fees. These pending fees are from trades. Pending vesting fees, total core in orders. I don't even know why that is there. Anyway, the most interesting thing is most recent op, because what happens is that when I transfer, this operation change, this object in the database changes. And the element that changes is this one, most recent op. This is going to be a new one. And now I can, of course, I could just, like, whenever I get something like this, I can RPC call client RPC get object of data most recent op or something, and then I can also get the actual operation that does something. And then we are almost at what is done in this monitor script. Go through it. Okay. So there's an on-account update that is called whenever faucet changes. This is the memo private key for the faucet on the testnet. So if you want to look into it, this is just a memo. You won't be able to get any data from it. But anyway, this is a private key. You get the most recent op over here, get the object from it. Operation ID is the actual ID of this operation. Get the corresponding account and get the whole account history for that account given the last operations. And then we process this operation simply by getting the operation that is transfer operation that looks like, let me just quickly show you how it looks like this. Take these operations, take a look at the fee, take a look at the amount, take a look at the memo. Here's the memo. I can actually decode the memo using the memo private key from above, and then can show the data I have received here and post-process anything. So this is actually everything you need to know to already understand this script that I used to code for exchanges in order for them to easily integrate into the network, BitShares network. Okay, so this was hell of a monologue. Are there any questions left for now? 2 minutes left for the end of this talk. How long did it take for you to get this awesome?
I have a question because this approach is very low, maybe not very, but it's rather low level, and I think you worked on some higher level API, am I right?
This actually is already the Graphene client. This is already higher level API. You could, if you wanted it even lower, you could use the Graphene API instead and directly connect to the network. The Graphene client makes it a little easier for you because it combines the witness RPC and the wallet RPC and kind of make them easy to use from just one object. So this client object gives you everything you need. You don't need to use the witness node at all, and you don't even need to use this one. In this example, we don't even need the clients for the wallet. We could just remove this and get the same data that will work the same way.
Yes, I'm not sure whether I heard everything. I was off for some time, but from what I saw, I still had to operate on IDs. Am I right?
The witness, if you want to deal with the witness node, you have to deal with IDs because the witness node doesn't. Usually all transaction kind of things are IDs, and the usernames are already like an abstraction layer higher. The wallet does usually know how to deal with usernames and exposes usernames to a user and not just the IDs. But you can also get all of the data out of the witness node. Let me take a look at client. There is a call. Let's move over this here. Oh, yeah, I'm doing it wrong. Second. Seems that it is not just not anymore. You want to do this now? Anyway, you can get, if you just have the name and you don't know the actual ID and have to still deal with the ID, you can still get this data from the database API. Let me just know what this call has been. Get accounts, get full accounts here. get account by name, it's called. You could run like this, and you would still get the account, including the account ID.
Yeah. Do you know, or are you aware of any other tools which could give some more object-oriented approach? But maybe this is a room for improvement. Yeah. That, for example, when I will use some API, get the account, I will specify a name, and then I will get account instance, which will have automatically will provide proper methods, which could make another request for other data, and so on and so on. Did you thought about that?
I have not thought about that because that's already a very specific use case. If it could be done, sure, could be done. Yeah, like an account control class. Yeah, actually, it would make a lot of sense because you can do quite some nasty things with accounts, like proposals or withdraw permissions. That's actually a good idea. I think I should do that. Yeah. Okay, there were some.
Make sure that this will also be open source. Then maybe we could all contribute.
It will certainly be open source. What else should it be?
Yeah, of course. Thanks.
Okay, there was one more question here. How would one go about structuring a dev for order book and orders? Actually, this is, yeah, it's not as low level as you could go because this one and this one and this one are low level. But there is stuff that is higher level than that. For instance, there is an exchange API. It's that one that exposes the whole exchange and trading kind of stuff to the end user. And I try to closely follow the Poloniex API here. It has commands like, where are these? There should be a list of them here. So this would be like how you use it. Stuff above is pretty much the same thing. You have wallet, host, witness stuff, markets you want to watch, so you get notified of them. A main account. In this case, I've just picked anything, and then you can create a DEX object. This would be pretty much like you would want this for an account, but this is just for the exchange, for the decentralized exchange. And then you can return trading histories, a ticker, 24-hour volume, order book, the order book for this, or any other, return balances, buy, sell orders, and there's also some more like calls like cancel asks out of range, cancel bids out of range, cancel bids less than, what's this? Get my asks out of range. Oh, there's so many of them. Get less than, get less, get low. There's also a withdraw operation that is not implemented because it doesn't make sense in a decentralized exchange. Anyway, you can cancel operations. There's also a borrow operation, a just collateral operation ratio. I hope I can finish up that one rather soonish. Same thing as a just debt. Closed debt position is the same thing. And yeah, sell, buy, and all these other kind of things. Yeah. If you want to have a look into all of these, there's documentation available. Read the docs. I think I mentioned it even in the README. Here. Here. This is the link you can follow if you want to see all the documentation for the exchange and all the other kind of things. Yeah, I try to include most of the documentation already into the source code itself as a source code comment, but there's also a docs subdirectory that has quite a lot of documentation, including stuff for the memo. How's the memo structured? How does it work? How could I decode a memo? It does not contain how to encode a memo, but it's pretty much the same thing, just like decode encode like thing. There's also description about how the WebSocket kind of things work. This is a regular demo how you could use the WebSocket connection like in any other coding language, not just in Python. There's also an example for the client library, which takes all of the data out of the examples from the source code. And yeah, as you can see, a bunch of stuff. Okay. And there's Graphene Base. This is stuff. This account thing here, it has nothing to do with what we just had. This gives you a rather very, very low-tech stuff like dealing with brain keys, dealing with private keys, with addresses, with hashing, with this is very, very low-tech actually. So I don't think that too many people will deal with that. Base 58 is just like an object that does the base 58 encoding. BIP 38 is encryption, so you can encrypt private keys. Dictionary is used for the brain key. This is the memo stuff. That might be interesting for some of them. How is the encoding happening? It doesn't look too complicated, actually. It really isn't too complicated. And this is something very new. And this will probably take more than just one live coding session. This class or this module will allow you to construct and sign transactions without using a wallet. So this basically shows how the wire format of Graphene actually works. And as you can see, it's a bunch of code. This is the signing stuff. This took me a while. And then currently I just only know how to, I only have it implemented. I know how to do the other transactions as well, or the other operations, but currently the only operation implemented here is the transfer operation, which is just 1 out of 43. More to come. Okay, there was another question. There's already an API for showing orderable. Okay, yeah, I think I answered that one. Good. We are almost 10 minutes over the time. I'd say I'm going to close this here. Hope you stay excited. Hope we can get another time for like doing a little more nasty stuff.
Very enriching content. I hope you continue doing these 5 sessions, please, so we can move forward to more abstract concepts.
I'd love to. There's a lot of stuff to do. For instance, there's invoice stuff. There's also something I recently wrote for setting up. This is a very, very, very interesting stuff when you can deal with the prototype kind of things of operations and fill in your operations manually. This is very, very powerful. You can do any kind of transaction. And then, of course, there's also something that I'm very excited in. It took me a while and might even take me some little more time. Let me just tell you this here. This is a nice example of how to use the exchange API call. Like, it just gives you a overview of how markets look. But what made me excited, and maybe some of you are already also excited, is the exchange bots. These can be used for automated trading bots on the decentralized exchange, and they are not yet as good as that they can run autonomously or like asynchronously. Currently, I would propose to run them with cron jobs, but all the infrastructure is in place to have them run like asynchronous programs that just run in the background continuously. Yeah. Okay. This is it for today. It was a pleasure talking to you. I'm going to stop broadcasting, and then maybe we can have a chat about stuff or anything.